So by the end of this week, you'll have a pretty good idea of how word problems are supposed to be addressed and tackled, okay? Right, inequalities and word problems. When given a word problem, you'll have to read and interpret the question. That's going to be in order to produce inequality, right? You're going to have to read it and then come up with your inequalities. You're going to have to write them out. An inequality essentially provides a restriction, right? Inequality essentially provides a restriction to possible answers to the question. Things to keep in mind when we work through this type of data that we're working with. We have discrete and we have continuous. I don't know if you remember that from IAPR. Here it is. Discrete. I feel like my pencil is going to break. Here. Discrete only exists in whole quantities. Some examples: coins, cans, people, cows, etc. Right? Like you at the end of the day, you have to round, right? So what we're going to do is, therefore, we round points of intersections or corner points. They're the same thing, okay? If you see corner points, it's the same thing as POIs. So we basically, example, so let's say you use your calculator and you get 6.918, right? For whatever reason. They could both be decimals. In this case, only the x variable is. I want you to still write it down like this. But then I want you to go arrow and say, hey, this actually rounds to a 7 and 8 because we're talking discrete data, right? So you need to have your numbers. You can't have 0.91 of a person or can or what have you, right? So just do that. That's the extra step you need to do there. Continuous exists as a decimal or partial, right? Partial amounts. Example, area, distance, time, temperature, money, etc. Right? Don't round. POI. Okay. So maybe I will just, right, if it's discrete, we round POIs. That's the important thing on this page, really. Just remember that. If it's not, don't worry about it. Nothing needs to be done. No extra steps required. Okay. So that I think it's important to identify that right off the top. Don't wait till the end because you're going to forget that. But if you tell yourself right away, oh, we're dealing with discrete data, then you take care of that later. Because the POIs happen at the very end almost, or close to the end. Next, we have a thing that we need to consider, just like we did in the quadratics unit. Almost all cases involve data that cannot be negative. Almost all cases have data that cannot be negative. Therefore, your graph will be restricted to quadrant 1. Graph will be restricted to quadrant 1, right? And therefore, we will state the implicit constraint. Highlight that, please, because I will ask you to state it, and it's really that easy. It's just to say x and y have to be greater than or equal to 0. So 0 or greater, so positives only, right? So this restricts it, restricts solution or solutions to quadrant 1. That's what that does. Okay. So I want to have this side by side. I used to not be able to do this, but because I have booklets now, I can just slap the graphs in there, as many as I see fit, right? And put them side by side. So if there's no context, if there's no word problem, no text around it, right? You would just graph as you have been doing so far. All 4 quadrants are included. Keep in mind there should be arrowheads everywhere. Desmos. If I do a screenshot, it doesn't do it. So anyways, there it is, right? But if it's a context, if it's a word problem, we're going to be constrained to this because of that. So let's copy. Let's first come up with the POIs approximately. This would be 12.9. 12.9, that's the only POI. Because this is your solution region, right? So in this case, you'd only have one. Okay. If you're dealing with a context, page 39, if you have a context, then let's copy these 2 lines onto here, but I'm just going to focus on the first quadrant. That's what this is for. So this is approximately halfway between 20 and 30. So I'm going to go there, make a point right there, halfway between 20 and 30. And if you follow this line, it goes to 20 here. So let's put that dot right there. So between 20 and 30 and right on 20, and we'll go ahead and graph that line. Is it blurry, guys, or is it just me? Maybe I'm losing my sight. Hope not. Maybe I need glasses. To me, it looks blurry there. But anyways, there you go. So this line will transfer over to here. So this graph would actually look like this. Okay. That's that line right there. And then the dashed line goes through just the one line above 10, make a dot right there. And it goes all the way to 40, which we make a dot right on 40x. So we copy those lines. And it's a dashed line. See it? So this is what it would look like if there's a word problem. Take a moment to copy this before I fill this in even more, right? So we copy this line. We stay to quadrant 1. We do not extend, no arrows going past, anything like that. It's just, it's a segment, right? It's just from here to here, from here to here for that dashed line, which we copied from over there. And then when we shade it, we are left with this. So make sure you just shade that little section there. So that's all false. And for the dashed line, it was above, right? So where's your solution region now? It's right there. It's right there. Because you have restricted it, right, to quadrant 1. So it used to continue all the way, it would go into infinity. This is restricted. So now, how does it change with the POIs, guys? This still stays the same. The 12, 9, nothing changes, right, the intersection there. But you have 2 more. You have this one that, like, when it touches the axes, that counts as well. So we'll put this down here. This is 20, 0. And this one is 40, 0. So you don't even need to calculate these. You would have calculated them anyways, right? When you find the x and the y intercepts. 3 POIs, and this is the only POI on there. So that's how it's going to be different between word problems. And some students have the temptation to, like, I'm just going to put an arrow here and continue it just in case, right? Like, no, don't do it. If it's a word problem, you stick with quadrant 1. Okay. I don't think I can be positive that you will not get anything in the other quadrants. It'll be quadrant 1. Okay. Let's keep going. I can let you look at it later. So let's go to page 40 here. I want you to practice this. I want you to see it today before we move on to graphing these things. Keywords. These are the keywords that indicate, pay close attention to this. If you see up to, maximum, no more than, at least, must have a minimum. Has a capacity of, anything like that indicates inequality, right? So you would have to somehow write out an inequality for that. If you see that, those are going to be the keywords I'm going to focus on. Write an inequality for the following statements. Notice, I'm going to use 2 different color highlighters. Let X be the number of people and Y be the number of pets. So the question tells us the difference, right? So now we know X is people, Y would be pets, okay? So this has been established. You've identified your variables. Let's say a statement reads like this. A building can accommodate, there's that should be a no more than 400 people. That right there should tell you, okay, it doesn't say a building can accommodate exactly 400. It doesn't say, right? It doesn't say that. It says no more than 400. It's an indication that you could have less, right? But no more than 400. So here, 400, we're talking people. So people would be X, right? Can I just highlight that as well? So this indicates inequality. This is the variable we're going to use. So that we will say that the number of people can be no more, okay, than 400. That's how you would write, that's how you would translate this statement into an inequality. Okay. Can I say this? There can be 400 or 399 or 398 people, right? That's what this statement is saying. As long as you're not above 400, you're fine. Okay. A dog park can hold up to 45 dogs. So inequality first, can hold up to, right? Hold up to or accommodate up to 45, and there is the dogs that tells us that the variable we're going to have to use is the Y. So Y, the number of dogs, has to be less than or equal to 45. What if this question would have said a dog park can have or must have a minimum of 5 dogs to operate? It would have been different, right? It would have been that Y has to be greater than or equal to 5, right? So read the, I can't give you all possible examples, scenarios, but I'll give you enough. A dog park can have up to 100 dogs. So up to 100 dogs and owners combined. See that? So we'll see, I got to get this straight here. Owners, right, would be people and dogs. So both variables. Hey, what's going on here? So this is now not specific to either dogs or people. This is both combined. So this is how you would do that, guys. If you were to take both of them, if you were to add them up, that has to be less than or equal to 100, right? You're saying that the combination of dogs and their owners, right, can be up to 100, but not more than that. So this is how you would write that. And later on, we'll do something else yet with the highlighters, so just hold on to them. I'll do that at the end. A vet can see up to 24 pets per day. There's that word up to. Up to, that's inequality right there. And pets would be that. So the vet can see up to 24, but not more, like that. A committee needs at least 5 members. At least should. It should indicate to you, okay, that's keyword for inequality. 5 members, that would be people, right? Oh, my bad. I messed up on my highlighting, right? I think you'll be all right, but minus 20 points for Mr. Dirksen. I don't know, keeping track of it. And so people right there. A committee needs at least 5. So which way is the inequality going to go here? If these are your members, that needs to be greater than or equal to 5. At least 5. So you can have exactly 5 or more. Okay. Can have 5 or more. Like sometimes students like to, and don't try this on a test. Like seriously, can you like reword this for me? Like don't try it on a test, but you can try it when you try ACs and stuff. I may give you a little bit of a hint from time to time at the beginning, but then later on the grace is gonna go ahead. A stadium allows up to 20,000 visitors and pets combined. So I'm thinking this is like a dog whisperer. I don't know if you watch that show, but he's throwing an event I was thinking at a stadium, and so you can have 20,000 visitors and pets combined. So let me get my highlighting straight here. Visitors would be people, and this would be obviously pets, no problem there. And we're combining them. So the number of pets, visitors and pets allows up to, you see that, right? That's the keyword. A maximum of 20,000 people. So that number of them combined cannot be greater than 20,000. Okay? That has to be less than or equal to 20,000. Two numbers. Let's do an example here. Oh yeah, this is what I wanted to do here. Whatever you used for people, right? I'm gonna highlight all the X's with the same color, right? So whatever you used for people, and then I'm gonna grab the one I used for pets. So all the Y's I will highlight with that color. So it comes alive. That would be one of your comments at the end. Calm down with your highlighters, Mr. Dirksen. Enough. Two numbers have a sum that is less than 20. This right here is less than right there. That should say, okay, yeah, that's an inequality right there. So write down IQ 1, inequality 1. twice the first number plus 5 times the second number is at least, that should ring a bell right there, maximum, at least, or something like that, 50. That's IQ number 2. So there's in fact a system here. We're not going to graph it, we're not going to solve it, we're just going to write it. So the inequality number 1, two numbers have the sum that is less than 20. Let's do this first. Let x be first number and let y be second number. That's going to be very important for you to, before you start, you identify your variables, you define your variables. So if it says two numbers have the sum that's less than 20, no problem. If I take these two numbers, that has to be less than 20. Notice that? It's less than 20 like that. Not equal to, it has to be less. Inequality number 2, twice the first number. Let's see if you can follow this. Twice the first number plus 5 times the second number is at least 50. How would you write that if you saw the at least? What symbol would go here? Greater than or equal to, that's right, 50. And you have yourselves a system, and you can actually graph this and have possible answers to this system. I just wanted you to see how that works. Okay. By the way, this example would span all 4 quadrants. Okay, this is not technically a word problem unless it said only positive integers are allowed, right? So this is, I just wanted you to have a go at it because sometimes they do show up. Okay. Okay. So before you go today, you're gonna practice a few on your own. Okay. I want you to write. We're not gonna graph today. I don't worry so much about graphing because I know you know how to graph at this point. So come with me to page 41. You know what? One second. There's a big chance that you're not going to. So 10 minutes on that. So I'll just write down at the bottom of this page, homework, page 13 in workbook. Just that one page. Rewriting. Write the inequality for the following scenarios. Okay, and I'll post this answer key for you to see as well. Okay, thank you guys. You've been great.